The LG Procast, the podcast, is intended for informational and entertainment purposes only. The views or opinions expressed by the podcast hosts and guests do not necessarily reflect the official position of LG. For the latest and most accurate information about LG products, please consult relevant product manuals and related documentation. The information provided in this podcast episode is for informational purposes only and does not constitute professional advice. While we strive to provide accurate and up-to-date information, we make no representation or warranties of any kind, express or implied, about the completeness, accuracy, reliability, or suitability of the information for any specific application in the following discussion. LG and those posting or otherwise providing information, content, or material are not responsible or liable for any consequences relating directly or indirectly to any action or inaction you take based on the information, content, or other material on the podcast.
Hey guys, welcome to the LG Procast. I'm your host Terry Fresenda, joined by Mr. Philip Craigmont. Hey Philip, what's going on, buddy?
Terry, man, we are down in Alpharetta, hanging out with a bunch of service champions from around the country, having a good time.
Yeah, man, it's been a bonanza of opportunities here.
You like that word bonanza?
I do, bonanza.
We had the builder bonanza the other
builder
day.
bonanza yesterday, and I was thinking about, some other topics we could get on. But you know what I wanted to talk about, Philip, today was, you and I have been in these classes, and we've been with this group for now a good, day and a half, and we have a service tool, the LGMV service tool, and when you go to these classes and you look and you learn about this tool, you realize, if you didn't realize before, just how powerful this tool is and the amount of information that's available. Because certainly we're selling an engineered product that is a technologically advanced piece of equipment. So, and I think this LGMV software tool is exactly that. So let's help folks understand that tool a little bit better today and talk about why and
it's the direction that the whole industry is moving. And we've made this analogy before. I have, the auto industry went from carburation to fuel injection back in the 80s and 90s. And when they did that, their diagnostic tools changed as well. They're not using timing lights and vacuum gauges to work on the carburetors because it's, that's a manual mechanical device. Now they're using scan tools to plug into the vehicles to see what's going on, and not just for air codes, which is part of it. Your check engine light comes on, go down to the auto parts store, they'll scan and tell you the code. Well, that's a piece of it. But when you actually take it to a mechanic, their computers do a whole lot more. They can look at every single component and sensor that's going on inside of that vehicle to do a true diagnostics, not just an error code check. Well, air conditioning has moved in that same direction. We're not using mechanical TXVs and constant speed compressors. We're using electronically controlled, computer-driven machines now that have sensors throughout. And so instead of hooking up a set of gauges to look at the pressures and getting the temperatures on the lines, it's a lot more advanced than that. So we're now plugging in, just like your auto mechanic plugs in his scan tool into your car, we're plugging in the LGMV device into our units. And that's how we are monitoring, diagnosing, checking error code. So if it does give you an error code, it'll tell you what that is. But, that's only a piece of the puzzle. If you have a unit that is not giving you an error code, but is not performing, we need to actually go in and do a true diagnosis of that. And that's where this tool is very, very important.
So you made a pretty important comment. If you've been to any educational classes that Philip or I or a couple of our peers around the country have had, we call those classes PWC, piping, wiring, and charging. For my entire working career here at LG Electronics and even prior to coming here with LG, we have spoken specifically about gauges never belong on this technology.
Right.
All right. These systems are critically charged. They have small amounts of refrigerant. We'll talk about very small amounts of refrigerant. And just a simple process of putting gauges on and off a system could adversely impact the charge. More than likely does impact the charge. So if I can't use gauges, which I've made the association in the past in these classes that I've held around the country, a surgeon has a stethoscope around his neck, right? And a doctor has a stethoscope around his neck, and you expect that because he or she uses that to start to gather information. As an HVAC technician, our stethoscope was that red, yellow, and blue hose instead of gauges,
Yeah.
right? So we crawled out of the truck and they were over our shoulder and we hooked them up immediately to gather the heartbeat of this system. And there's just there's more information needed than gathering just the heartbeat of this system now because to your point, they are controlled with computers, they are controlled with electronics, and so we need to be able to take all this information from all these devices and bring it to a system that we can see.
And it's a comfort level too, as technicians that have been in the field for a long time. But it's one of those things that we just have to get over and get educated, right? So education's a big piece of it, and just learn to use these tools. Um, First of all, you have to have the tool,
Right?
and LG has done a great job of keeping it very affordable. There's a couple of different models. I don't know if you want to hit that. There's
Yeah.
two different models
Yeah, I
of
think
it.
they do. Absolutely. So you have two versions. You have a wireless version, and you have a wired version. The wired version obviously works through your laptop. It requires a Windows based program to operate.
Not a Chromebook.
Not a Chromebook, but it actually has to have Windows. Um, the wireless version works basically through your phone through an app.
So the wireless one creates its own or wireless
I know.
network, Wi-Fi network, and then your tablet or your phone through an app connects to it. However, they've also updated that where now if you're using the PC version, you can either use the wired one or the wireless. Now the wired one's going to give you a lot stronger connection, more reliability, faster connection, all that kind of stuff. So depending, are you on a large commercial job? Are you on a residential job? What are you trying to do with it? May direct you one direction or the other, but if you're going to buy one, I would start with the wireless one. Can work on your phone, your iPad, your computer, all the above. But and maybe we jump forward. I do want to stop and talk for a second about the gauges and what are some of the reasons why we don't want technicians using gauges on a system? And when we say gauges, we're talking about a traditional manifold
Right.
set with the hoses. We're not talking about new probes. Probes are great. They
Right.
have a place. And we use something similar in our install practices. So I want to talk about the dangers of using a set of gauges, and then how to maybe we can even talk through the steps of an installation without gauges. Because a lot of guys are like, well, I don't use it for service, but of course, I have to use my gauges to do an install. And
That's not
right.
right. No, it's not right. No, I don't have them. I have a single hose.
Yeah.
Right. I have a hose and a core removal tool and
Yeah.
a nitrogen regulator.
Two hoses, one to vacuum and one to
charge.
pressure test and charge, right?
Yep. Right.
So what are some of the dangers of, why not?
Well, for, we spoke about it because we are critically charged. Like, look at some of these systems. Like, if a 1 ton system for LG, one of the 1 ton systems we have has 29 ounces of refrigerant. As
Yeah,
the charge,
R32 got charges. The charges got even smaller.
right, even smaller, right? So 29 ounces of refrigerant in a 1 ton, one of the models from LG, 1 ton system, good enough for 25 feet of refrigerant.
Right. So if you hook up your gauges and you extract 3-ish ounces,
10% of the charge.
yeah,
That's
yeah,
10% of the charge.
just from hooking up, and that's assuming that it doesn't spray all over your hand and leak out.
And people think, "Oh, it's ounces." Okay, well, so think of a big system. Let's think of a system that's got, you know, 10 pounds of refrigerant in it. What's 10% of it? That's a pound of refrigerant. Is that a system that's gonna not perform correctly? You bet your bottom dollar it is, right?
Yeah,
And so when we use the term critically charged,
it is.
that's exactly what it means. It's critically charged. And these older practices, that were tolerable
To some degree.
to some degree, um, are not tolerable
Yeah.
now.
I mean,
And they show up quickly.
a 3-ton system has just over 6 pounds in it, pre-charged.
Total for 25 feet.
Yep.
Yeah,
What about the oil?
yeah. I mean, we use PVE oil, and the other manufacturers don't use PVE oil, and the oils aren't compatible. So if there's the risk of cross contamination, so there's that. So there's just a lot of reasons, that if I'm in this business and I'm doing this work as a contractor, I mean, I make these conscious choices to do things right, which means I have tools that are associated for doing this work. and doing it correctly. And
Mhm.
the processes can be exactly the same. The processes that I use for, and you and I talked about this to contractors in education classes, the principles and processes that we teach you or educate you on for doing this inverter driven work are just as valuable, if not equally valuable or more valuable when you're doing the stuff that you do, the legacy work that you do every day. If you can learn a better evacuation process by using better tools and you improve that process and the time it takes to do that process, you're better in both segments of your business,
100%.
right?
Yeah, I mean,
Better in-
part of the class that we teach that it is relevant, but it's not specific to LG or to mini splits or anything like that. Is we go through a vacuum class, real quickly, and I love to ask the guys, hey, how long does it take to run a vacuum on an average residential system? And it's 30 minutes, 45 minutes, and then we talk about how to do it.
Right.
So, how about you go through and take us step by step how you would do an installation with no gauges? Like what tools are they gonna need? And what order do you do the process and how do you make that? I wish we had the tools with us for the guys watching on YouTube, and we don't have our tools with us, but can you talk us through that process?
Sure. So I said before, so I have a tool bag that consists of a core removal tool. And
Mhm.
actually I have two, and we can talk about why I have two, but I have a core removal tool, which is just part of that whole process for evacuation. I have two hoses, one set up for charging and nitrogen for leak testing, and then one set up for evacuation. Obviously, it's a larger diameter, which allows me to evacuate faster. I have a vacuum pump
Mhm.
with fresh vacuum pump oil, and I have an electronic scale.
Mhm.
All right. I got a 4.5 millimeter and a 4 millimeter Allen wrench to open service valves.
Any gauges at all?
No, I do. I do. I have digital. Thank you for prompting me. I have a digital set of gauges that I use high side, low side. The high side I use for charging nitrogen because it goes up to 800 psi. The low side I use, or I'm sorry, the not a low side, but a micron gauge, and I use my micron gauge for exactly that, for developing my
These gauges have no hoses,
no hoses. They quick connect fittings to my core removal tool.
or you could use probes if
You could
you own a set
yep,
of probes.
if you use probes, absolutely. I don't. But that's it.
Yeah.
So
So how do you do that?
all right.
Step one.
So step one would be I've made my refrigerant connections and I've done all that. So it's time to do leak test.
Yep.
And in this educational class, I tell everybody, I don't care what system you're working on in the world. If it's an HVAC system, there are three steps, right? There are install, like leak test,
Mhm.
evacuate, and if the
Mhm.
system needs refrigerant, you charge, right?
Yep.
And I tell everyone there's a new word for y'all. Okay. And that new word is pass.
Yeah.
All right. And that's leak test pass, evacuate pass, charge pass. Because if you left one of those steps before you passed, you have a system that's not going to pass. It's going to leak refrigerant.
Yep.
And you're going to be back running a service call. So under that system, I've made my refrigerant connections and it's time to leak test. So I'm going to put the nitrogen into the system. First thing I'm going to do is connect my core tool, remove the core.
Say something about the core tool because we have 5/16 fittings, not
Right,
quarter inch. So
yep,
that
so-
mini split adapter that most guys are using, I don't have.
I don't have one. I buy a core tool removal that has a 5/16 on one end, a quarter-inch refrigerant and flare fitting on the other. So hose connects to the quarter-inch side like all standard stuff. 5/16 connects to the side. My core tool is rated to, I think, 50 microns, maybe 5, but it's very low.
Yeah, there's several good ones out there.
So they're getting better by the day. So I connect that, pull the core, and then connect my hoses and introduce nitrogen to the system. I typically will start with 200 or 250 psi, depending on the length of the line set. Ball valve. My core tool has a ball valve, so I can ball valve down.
I think most of them do.
I got my high pressure gauge connected that side of the ball valve, not connected to the hose or somewhere down line. It's
So the core removal tool has 2 ports, right? One on the back
correct.
that you're gonna hook your hose to, and one on the top
Top
that you put your high
which
pressure
had a
gauge on.
Schrader fitting in it,
Yes.
so that you don't lose. That's the one that my gauge is going to, or my high pressure gauge is going to. So put the nitrogen in, and listen, here's the deal. In the past, I used to call it the nitrogen head trip. You guys would look at a set of gauges, not digital gauges, but analog gauges, and they would see the leak with nitrogen and hope and pray that they didn't have a leak. So they would just move their head a little bit so that the needle would go back to where.
Yeah.
But one thing about a digital set of gauges, when you put 250 in, and a couple of minutes later you have 220, you have a leak.
For sure.
All right. It's not doing anything other than that. Right. So digital has taken the guesswork out of whether or not I have a leak.
Mhm.
All right. So I put that 250 in. That at a point, I would put some leak detecting bubbles around, look for leaks on and if you're doing a system, we talk in class all the time about the biggest ductless systems are installed one to one, and it's a exterior wall application, and the line set's running down the exterior of the wall. Listen, if I'm doing it, all my refrigerant connections are outside the wall, right?
Yeah.
And so I'm looking
Most
for
of
leaks outside the house, outside the wall, and I'm putting soap bubbles on them, and I'm putting 250 psi nitrogen. And if I don't have a leak at 250, that's when I'm going to bump it up to the 550 we recommend as a manufacturer.
Yes.
And if I don't have a leak, pass. At that point, I can proceed forward with the next step, which is
Those
exactly
digital gauges are gonna tell you, if it sits there for a little bit and you went from 550 to even 540, on an analog gauge, you're probably not gonna see
not going to
that.
see that.
But on a digital gauge, you're gonna see that because nitrogen does not change much based with weather. So, I mean, it takes 10 degrees of Fahrenheit to take 1 PSI of nitrogen down. So, unless you have drastic swings in your weather throughout the day, your your pressure should stay exactly where it was.
Absolutely.
So if you've dropped, obviously it takes a few minutes for it to settle out, but once it settles out, it needs to stay.
So, and so you ask again, why not gauges? Why not hoses? Because every one of those connection points is a
Mhm.
potential spot for a leak to develop. And if you're managing critical charge refrigeration equipment and you got 8, 9, 10 fittings from hoses and manifolds and all that stuff, man, you're just asking for trouble.
Well, we were on the phone a couple hours ago with a contractor and said, I left it for 30 hours and I lost 10 PSI. What do you think? And he was telling us, well, I did have my manifold on it. And so that's one, two, three. I mean, at least a handful of O-rings. I said, why don't you go back and recheck? And he goes, all right, I'm going to go back. I'm going to take all that out and just put a micron gauge on there and see,
Yeah.
or not a micron gauge, but
High pressure gauge
a
or
high pressure gauge on there and redo it because he wants to do it right, which I appreciate.
yeah.
Do I think he has a leak in the system? Not likely. I think it's probably in one of those O-rings, most likely, but let's be let's be sure.
Yeah, let's eliminate the
Yeah.
process, right?
Okay. So we've done the pressure test.
Right.
Pass.
We passed,
So now we need to vacuum it.
right? Which means I got to get rid of my nitrogen. So I've got that ball valve, I got it closed, I got the hose connected,
Yep.
right?
Yep.
So now I can take the hose off, or I can leave the hose on, take the high pressure gauge off, right? That's just a process for me. And then I can disconnect the other end of the hose from the nitrogen tank regulator.
Yep.
And I can open the ball valve, dump in the nitrogen. I got the ball valve on the tool. So once I get the nitrogen out of the system, I can close the ball valve down back at the service fitting. Okay.
Mhm.
Now I can take that hose loose. From the fitting, connect my evac hose.
Yep.
Okay. Connect my evac hose to my vacuum pump.
What type of hose?
Evacuation hose. It would to be non-permeable, which would probably be black in color,
What size?
1/2 inch minimum.
Yeah.
Okay.
1/2 inch is rated for 4 CFM, by the way,
Right.
at 1,000 microns.
And if you got an 8 CFM pump and you don't have a 1/2 inch hose, then you don't have an 8 CFM pump.
Not at all.
Bottom line.
Yeah.
All right. The reason we pull the core is because if you don't pull the core, it doesn't matter what you have.
It's like less than 1
it's like less
CFM.
than 1 CFM. So
And with the core out, it's 10, I
10,
think.
I think 10 is max, right?
Yeah.
All right. So vacuum pump connection, right? Ball valve is still closed. Okay. Now listen, we talked about this process. One thing that we want to help you understand is if you will screw your micron gauge to the top of your vacuum pump, right to the fitting directly, and turn your vacuum pump on, and if it doesn't pull it under 500 microns in just a few seconds,
500 microns, 5 seconds.
it's time to change your oil.
Yep.
All right, because it's saturated and it won't get to 500 microns, or it will get there at a very, very, very slow rate. This is when I talked about this process is even more critical or even more beneficial for larger systems.
Yeah.
Because you're never going to get to 500 on a 5-ton system.
So this is a test that in 20 seconds, you can put your micron gauge on the pump, turn the pump on, see if it'll pull down, and you can know instantly, do I need to stop what I'm doing and go change the oil, or can I go ahead and proceed with what I got?
All right. So we passed our micron test there. So now I'm connected to my vacuum pump. The ball valve is closed. I turn on my vacuum pump now.
Yep.
And I pull a evac from the vacuum pump to the ball valve. on the hose.
Suck your hose down.
Suck the hose down. Once that happens, that's when I open my ball valve to start evacuating the system. And everybody's pump's different, but everybody knows the change in tone from the vacuum pump when it does that. So now it's beginning to evacuate the system. Some folks will screw their micron gauge on at that point. I probably have already screwed my micron gauge onto the system for me.
Yeah, I did.
And I can see from a digital start, it starts at 760,000 microns. And it begins to immediately pull down. And if I pass that test we did, and we know we got fresh oil and all that's working correctly, you will be amazed how fast you get to the 2,000, 2,500 micron range.
Yeah.
And then you'll see it start.
Couple of minutes.
You'll start to go to work. All right. So we're going to pull it down to under 500 microns.
Yeah. So I want to make a comment about the micron gauge being right there at the core removal tool. It's still very close to the pump, which means that we're going to read some of the low pressure on the pump side. Ideally, in a perfect world, if we have both a high side and a low side port, we could move the micron gauge to the opposite port, which means we're reading through the line set, through the coil, and back down the other line.
Great suggestion.
So if you have that option and you have the ability to hook it up on the high side, great. Then you're reading as far away from the pump as possible. And so what I tell guys is, when that gauge shows 500 microns, you're really not at 500, because as soon as you close that ball valve, you're going to have a lot of degradation and rise there. So pull it extra deep is kind of my point there.
Okay.
But sorry, go ahead.
No. That's super information. So then once I close that ball valve, I'm looking for that degradation that Philip talked about. How far is it drifting back? And there's, I don't know, you can read half a different stories from people about degradation and where it should go. But listen, if it gets back over 1,000 microns in a couple of minutes, I'm not happy about that.
Yeah, typically I want it to hold under 500.
Yeah.
At least a little bit.
I want it to hold underneath it, right? So we passed.
Yep.
Okay. We passed. I've got a vacuum on the system. The ball valve's closed. My micron gauge is steady. I can disconnect the hose from the ball valve. I can go back to the hose I used for adding.
So let's say we don't need to add.
We don't need to add. We're done. We can put the core back in the system, right?
Power it up, turn it on.
Power it up, open the service valves with that 4 or 4.5 millimeter wrench you own, and power it up.
So how do we know if we need to add refrigerant?
If you need to add refrigerant, the length of your line set determines that. Most of our systems come pre-charged for 25 feet.
Single zone.
Single zone. So if you're more than 25 feet, you need to add refrigerant, right? And we'll do another podcast on the formula. I've been wanting to do that one since we started this program. So
yeah, it's really simple.
It's fast, it's quick, it's
every
simple.
bit above 25 feet, there's a charge multiplier. You multiply that by the extra length that you have, and
that's it. It's that simple. I don't need to measure anything. I mean,
what are the steps? You can't charge with subcool or superheat, right?
Nope.
It's all weighed
all
in.
math.
All right.
A minus B times C equals Y. A is the line length minus the jobs minus the pre-charge length times the multiplier equals the charge. Period. A minus
so you
times.
You did the math. You need to weigh in whatever X number of ounces, 8 ounces or whatever. What are the steps?
It's easy. I set up my electronic scale, right? I connect my hose to my refrigerant cylinder. I turn my refrigerant cylinder upside down and open the valve. I set it on my scale. I then purge refrigerant to my ball valve, which means I unscrew the fitting just a little bit to get refrigerant to this point.
That's important.
That's important because I'm zeroing a scale right at that point. Once I have refrigerant coming out of this little fitting, I can tighten that fitting back, which stops the refrigerant from leaking out, zero my scale, open my ball valve, and add the refrigerant at that point, okay?
So use the ball valve on the core removal tool to meter it.
Absolutely, because, man, when you're in a deep vacuum like that, refrigerant gets added very quickly.
Yeah.
All right, so
crack it open.
Crack it open.
Don't wide open.
Right. Put your refrigerant in the system. Once it gets in there, close the ball valve down. You can now disconnect the hose from there. The ball valve's closed. You can reinsert your core tool, reinsert the core, take the tool loose, open your service valve fittings, apply the power, and you got a system that's properly charged. Guys, the LGMV tool.
Yeah, so let's get into that. We don't have a ton of time left, but let's talk about the tool and what does it do?
The tool gives you all that data that you used to capture from a set of gauges. It gives you operating pressures. It gives you pressure and temperature sensor readings on the systems that have those. It gives you the hertz of the compressor. It gives you the voltage in and the voltage out of the boards. All that data
Yeah.
that's contained in that computer that you're selling that's making air conditioning and heating is captured by that service tool.
Yeah, and I mean, expansion valve positions and all sorts of stuff. So, we've got a system that's having an issue and we're trying to find it. That tool is gonna let a technician use the understanding and the skills that they have as HVAC professionals to diagnose the unit.
Right.
But if it is something where, okay, I can't figure it out myself, and I'm gonna call one of our service champions at one of our distribution or rep partners, or I'm gonna call LG Tech Support, they're gonna ask you questions, and beyond that, the other ability that it's
Tool
gonna
hooked
do,
up.
okay, so let's say you've got something, and I had a situation, in South Carolina a couple of years ago, and it would happen only under certain temperature conditions and the middle of the night. It was like 3 o'clock, 4 o'clock in the morning. This unit would get some temperature swings only when it got cold. And so what they ended up doing is they set up a iPad or computer or something, and they recorded the run all night
Like a
long.
black box recording.
Yeah. So instead of the technician having to sit there at 3 o'clock in the morning waiting for it to happen, they just recorded the run all night long. And then they were able to find the section where it did it. They took that hour or whatever, and they emailed that into our tech support team. And they're able to take that data, put it onto their computer, and play it back like it's happening live. And they were able to go, and forgive me, I don't remember what it was, but they were like, that's what it was. And that's how they were able to find that oddball problem that happened at, the middle of the night.
Gotcha. Interesting. Yeah,
It's
you wouldn't,
fantastic.
like you said, you wouldn't find that sitting there with a set of gauges connected
Oh,
at 3 in the morning because you'd be mad, number one, that you're there at 3 in the morning.
yeah.
No, Philip, this LGMV tool, it's just another example of the commitment that LG has for this technology and has for this segment of business in our country. Trying to do the best job that we can to give the information to these service technicians, service champions, and make sure that the product that we're selling, because again, like yesterday's Bonanza show, right? We're we're making whole home heating and cooling.
Mhm.
This isn't supplemental heating and cooling.
This isn't little garage mini splits.
This isn't a porch air conditioner, folks. This is a high performance heating and cooling system, dual fuel, heat pump, cold climate, all of that, right? All controlled by these electronic devices. And so having a service tool that can do that, LGMV, that's a benefit.
Yeah. A couple notes on that. One service tool, every single product LG makes, from a 9,000 BTU wall mounted air conditioner
Do the inverted,
F,
right?
to a 20, 30 ton.
Inverter scroll chiller.
Yeah.
Yeah, we don't care.
Big chiller. Everything works on the same tool. It plugs into the outdoor condenser. From there, it sees everything. On some of the commercial equipment, you can even control all the indoor units from the LGMV. You can send commands. You can get into the hardware configuration tool, and you can actually go into the settings of each of your indoor units and set your static pressures and set all those things from one place instead of going to.
That's service friendly.
Yeah.
That's service friendly for
I mean,
sure.
it's a huge time saver. So instead of going to 15 different indoor units on a larger system, you can sit there and do it from your
From that
computer.
outdoor unit
Quick.
system. Perfect.
Yep. So it's great. Where do they get it? Any of your distribution partners, any of your applied reps, they all have them either available or.
Yeah, it's a partner
ordered.
in our system.
Yeah, it's something that is affordable.
Well, man, I know we had a lot of information for these folks today,
Yeah,
and hopefully they
I think
find
it was helpful.
hopefully they find some of it valuable, right?
Yeah,
Um,
that's the goal.
I know we've been around the country a bunch helping with this install stuff on the PWC side, so glad to talk about that finally a little bit. Yeah.
That has been a phenomenal course that you and I both teach. Terry created this years ago, and I was able to take his presentation and kind of expand on it and build out some of the PowerPoint slides. And now there's several of us that give this presentation for contractors around the country. And it's not a substitution for coming to one of our full-blown
No means.
install classes, but it kind of gets you those essentials that you need to at least get comfortable doing a little bit. And so it's been a great class. So a lot of these guys have probably been to one of our classes, or Charlie's or Ken's or whoever else out there has been doing it. But yeah, hopefully it's been helpful. Hopefully this podcast, I think so.
Right,
Yeah,
yeah.
walk through some of the critical steps there that are
No, I agree.
most important. So Anything you want to add before we close?
Nope. I guess we'll be back sometime soon. So
guys, thanks for joining us for the LG Procast. I'm Philip. This is Terry, and we will see you next time.
See you guys. Bye now. Bye-bye.